Hi, my name is Gottbrath. I'm the Principal Product Manager at RogueWave Software. We're a vendor of tools, components, and libraries that specializes in high-performance computing. So our goal as a company is to make sure that programmers all over the world who are working on high-performance computing problems or kind of mission-critical enterprise problems have the tools and components that they need to do their job. I focus on the TotalView debugger, which is a parallel multi-process debugger. So that's the sort of piece of the business that I focus on, but we also have mathematical libraries and source components that you'll find will be useful. We're here at Supercomputing in Denver, Colorado, and the new thing that we have today, now, is a new version of TotalView. It's actually not quite released, it's in beta testing, but it's an open beta, so anyone who would like to kick the tires is encouraged to go to our website and sign up. What you'll find there is a new version of TotalView where we've been focusing recently on heterogeneous architectures. TotalView for a really long time has supported MPI, OpenMP, so parallelism in the way that you would see in sort of a classical clustered environment, where you have homogeneous nodes that all look the same, they all have the same processor. What we're seeing today in systems is a lot of systems with accelerators and co-processors. So they have multiple components, multiple architectures within the node. And they're also clusters, so we're adding another degree of complexity. What we've done with TotalView is we've extended TotalView's debugging interfaces so that it can support both of those models. So there's NVIDIA's GPU accelerators and there's Intel's Xeon Phi coprocessors. Regardless of which kind of those two technologies you're interested in, we support both. And in both cases you can debug both on the host processor, so usually these things are attached, so there's some part of the code that's running on the host. You can see all that code, and you can also see all the code and what's happening on the accelerator or the coprocessor in the same debugging session in a very seamless fashion. So that's, we think, a really, really powerful model. So as you're moving forward, and if you want to adopt these technologies, and if you're trying to get performance out of your cluster, which you almost certainly are trying to do if you built the cluster, then you're probably going to be looking at one of these two technologies in the future, and TotalView will be there for you. Now, we think it's really important to have a debugger when you're doing that, because you're really adding complexity. Now, it's good complexity. You're taking advantage of this new hardware, but you are adding complexity to the model. So, in some ways, I think the world of HPC a few years ago was actually simple. You had MPI and you had cluster nodes, and you optimized around that. And we just think that's kind of gone. It's very likely that now and in the near future you're going to be dealing with this extra degree of complexity. So you want to have a debugger that can do that. So that's what we've recently announced. That's a trajectory for us. We're going to continue to support more and more technologies that use these accelerators and coprocessors over the next year. Another thing that we have is sort of an initiative with TotalView is scalability. So TotalView's worked in clusters of up to thousands of nodes for a long time, but people are building clusters with tens of thousands of nodes. If you start looking at the numbers of cores, we're talking hundreds and thousands and millions of cores. There are a few systems out there that already have over 1 million cores, and when people are looking forward a few years, they're talking tens of millions of cores. I mean, it's just going kind of through the roof. So to make the debugger be able to handle that, we're in the process of retooling the way that TotalView communicates internally, so that TotalView can handle that massive level of scalability. So that's been a project that's been ongoing for a little while. There's an early access program. I'd encourage people to sign up for that if you have a big cluster, and you can help us tune that. We're also working over the last year and over the next year to redo the GUI of TotalView. The GUI is the graphical user interface. We have a very powerful GUI, but it's got a sort of a dated style. We're going to revitalize that with a new GUI. Now, what'll that do? It'll look cooler, but it'll also give us a lot more functionality, a lot more flexibility. So as we scale up, as we scale out, as we adopt new technologies, we'll have a lot more flexibility for what we can do in the GUI. It'll feel better for you. It'll look better. It'll be easier to adopt, easier to use. So we've got a lot going on with TotalView. I think I covered three things: scalability, the heterogeneous nature of modern systems and how we support that, whether it's NVIDIA GPUs or Intel Xeon Phi coprocessors, and a new GUI interface. So that's what we've got. And again, we've got a beta that we've just released at this show. I'd encourage folks who are interested to come to our website, learn more, and while you're there, sign up for either an evaluation copy of the shipping version or for the beta. Again, it's a public beta, so anybody's welcome to participate. Give it a try and see how it works in your environment. There are two tools in the space of parallel debugging that you may have some familiarity with. There's Alinia's DDT and TotalView, and they're both significant tools with a certain amount of market adoption. What you'll find if you look at the differences, if you want to compare the two, are a number of different things. And let me make sure I hit them all. So one of them is that TotalView's architecture is very different. So we build TotalView with the assumption in mind that on your cluster, you are using the resources on the cluster. We architect TotalView to have a very lightweight agent which lives in the which we start up on the compute nodes or near the compute nodes to control and monitor the processes. We really work hard to make that agent very small, very lightweight. It's not going to take up very much memory. It's not going to use very much compute resources. This is important because you built this cluster to do your work. Maybe something's going wrong. You want your tool to be able to work in that environment. In particular, maybe you're dealing with a memory error. The alternative architecture, which Alinea uses, is very heavyweight in the nodes of the cluster. They put an entire debugger in there for every single process, which has certain advantages, but what you're giving up very significantly is a large fraction of the cluster. You will have jobs that you're running on your system that you will not be able to debug with that architecture because you'll have to sacrifice half of the resources of the cluster or more to do redundant debugging work. And we just think that's silly. If you look at a couple of important features, memory debugging and multi-thread control, we both claim to have support for it. But if you really scratch beneath the surface, beyond the checkbox, as it were, you'll find that there are very different functionalities. So we support full asynchronous thread control. You can do thread width breakpoints. You can do thread groups. You can work with those thread groups. We automatically maintain the thread groups as the process changes. There's a lot of things that happen there. And the thread control that Alinea uses, they rely on using GDB, are limited by GDB's capabilities. And GDB honestly is not designed to be a multi-process debugger. These notions of groups and things like that are not part of its model. It's its whole sort of brain idea of what a process is. So you're going to find very significant limitations there. Now, that seems like a detail. But what is everybody doing? They're multi-threading their code. They're making them hybrid. This is the key part of what you're probably doing, and where the bugs are that you're going to need to deal with is in threads. So don't go into that with a hampered thread model and with a debugger which is not really designed for threads fundamentally. The other area that I mentioned that's like that is memory debugging. We both have something we'll call a memory debugger. But if you look beyond the first checkbox and look at the functionality that those had, you'll see that there's very significant differences. So, and again, I always hesitate to characterize their tools because maybe they've just released a new version that changes all this. But in the past, their memory debugger basically just gives you a sense for where the biggest allocations are in your program, and kind of stops there. Memory leaks can be a big issue on these kinds of systems, and I think it's important to be able to track a memory leak even if it's just one byte, one block. TotalView can do that. So it's just a quantum difference. You have a tool that can just tell you about the biggest allocations, whether they're leaks or not, and another tool that can tell it you can have 1 million allocations, and if one of them is a leak, we'll tell you that one is a leak. I think that's important. Similarly, another thing that people are doing with memory debugging in the memory debugging space is about optimization. So TotalView's MemoryScape functionality is really designed to give you the kind of filtering, the kind of sorting that you can go in and really understand how your program is using memory over time and with different data sets and things like that. It's just, again, a heads and shoulders, quantum different, it's just a different thing, much more powerful. Another thing is the kind of company that we are. So RogueWave is just a much larger, more stable company. And we have a range of different products. We've been around for a long time, and it's just a much more well-tested, stable product by a company that's got a lot of weight behind us. RogueWave software with our TotalView product helps out a wide range of different companies, like laboratories, national laboratories, and regional laboratories, and also universities with the TotalView products. Some of our customers that you may have heard of include some of the weather labs, both in the U.S. And in Europe, such as I'm trying to think here of people who've done press releases with us, like the Danish Met, for example, uses TotalView. We also work with some of the national sort of academic centers, supercomputing centers that support academic kinds of work, such as Daresbury, up in the north of England. That's a Science and Technology Facilities Council, Daresbury lab. They're users of TotalView and actually also collaborate with us on some research areas. That's something we're very happy to do. Another similar lab that we work with is over in the U.S. is Beacon. ACES is the name of the laboratory. NICS and it's the name of the system is Beacon. That's a Xeon Phi based system. Which is being used to try out new technologies and help people understand how to port and optimize code for this for the new many-core architecture. They've been using TotalView and have had some good success. You can see some more information about the Beacon experiences on our website. I encourage you to do that. We also have customers in industrial areas such as aerospace, oil and gas customers, financial services customers, some digital content creation. One thing I think is kind of cool is I've gone to more than one animated movie and been able to recognize the names of some of the people who scrolled by on the credits screen because they'd filed bug reports on TotalView. So I always thought that was kind of fun. So there's a wide range. What I'm trying to get at here, I guess, is that there's a wide range of different kinds of customers. They're doing different things, but in all cases, they're working with mission-critical code that really is important to them. It needs to work right, where they're putting a lot of effort into it, and they need to have productivity in that effort. And often they're also working with parallelism, multi-threading, and really taking advantage of some of these technologies. That's where TotalView really shines. That's why we have a really strong business with these kinds of companies. Of course, I can't answer a question about where TotalView is used without mentioning Lawrence Livermore. They've been really strong proponents of TotalView for a long time. We've learned a lot from working with them, and of course they have some very nice large systems that they've been very generous to allow us to take advantage of. One of the examples of that is last year we did a scalability test of TotalView using the Sequoia system, which was for a while #1 supercomputer in the world. It's been eclipsed since then, but it's still a very large system. And we scaled up TotalView across a job that was running on 786,432 cores, and we're able to debug that with TotalView. So that gives you an idea of the kind of, that's the resource we could never have access to or build ourselves, but in order to allow them to have productive use of their scientists' time, they value TotalView, and we work together to try and make TotalView meet their needs. So we've got lots of customers like that, from big organizations like that down to universities and small companies. Another example I can mention is in Germany we're working with an industrial company that builds like checkout systems in grocery stores. I always find this really interesting that they were tackling some of they were using TotalView. They were using it really well at a very advanced level. And what they were doing is their program, which runs on the checkout machine, had like 116 threads. And it was super valuable for them to have TotalView give them the asynchronous thread control that I mentioned before, that ability to control individual threads and to work with threads, work with groups of threads. And I was wowed. I got some of the best technical questions I've ever gotten from a group of users, and it was very far from the HPC centers that we work with a lot of times. So I think we have a wide range of different customers, all of whom see value in the kind of capabilities that TotalView brings.